Hi guys, this is the last video for operations and fractions. This video specifically concerned on the practice exercise D found in your module, lesson 3 of unit number 3. This video will only talk about demonstrations and discussions of those practice exercises. In the previous 3 videos, we were able to add, subtract, and multiply fractions. Now, we are going to learn how to properly divide fractions. So let me share to you the screen containing the material of lesson number 3, operations on fractions. As a reminder, this operation of fractions is just the second half of the operations on rational numbers. In the previous module, our previous lesson, we talked about integers. So this video will complete the operations of rational numbers as we finish this. So we will skip immediately to the practice exercise D as it is our concern for this video. So we have 4 items still for letter D here, numbers 1, 2, 3, and 4, and we need to get the resulting value for each of the situations. I have already placed this practice exercise in a paint application software. So let me share this to that to you. Okay. This is where we are going to scribble all of our solutions. Okay. So again, we are going to divide fractions. But before we deal with items here, we similar to the subtraction of fractions, there is a possibility that instead of using subtraction of fractions, we can manipulate the operation and make it addition. Because addition of fractions is easier to solve or to look at than subtraction of fractions, especially if we deal with plenty of negative signs. Similar to this situation, we have here a very important process when we divide fraction. Well, other references, other teachers of yours, other books will tell us the concept of cross multiplication. Well, actually, that is also a technique that is also acceptable. But as of our class, we are not going to. It's not like we are not going to, but we are going to use a better process than cross multiplication. We are going to use the concept of multiplicative inverse. The multiplicative inverse is also commonly called the reciprocal. So if we have a value here of 1 over 5, its multiplicative inverse is if we're going to get its reciprocal, change the uh, change the numerator to its denominator and denominator to its numerator. Therefore, its multiplicative inverse that is not equal. Multiplicative inverse is 5 over 1. If we have negative 2/3, its multiplicative inverse is 3 over negative 2, or can be rewritten as the negative sign at the numerator or in the middle. Okay. So that's the concept of multiplicative inverse. And how is it very important in our discussion? Now, our problem is all about division. So let's talk about number 1. 3/5 divided by negative 7 over 5. Okay. Instead of using the division process, we could just simply convert or transform or change the division process into a multiplication process. Because if we're going to use multiplication of fractions, it's very easy because as you multiply numerator to numerator, denominator to denominator, it's easier to look at that. Okay, and of course, similar to multiplication of fractions, here in division of fractions, we don't necessarily need the concept of similarity. Okay, in number one, we're just lucky they are similar, but we don't actually need the concept of similarity. Going back to multiplicative inverse, we are going to transform the process into multiplication, and by making the process into a multiplication, we need to transform the divisor into its reciprocal. This first item here is called the dividend, the first number in the process of division. The second number in the division process is called the divisor. So please do not interchange the two, because when we talk about multiplicative inverse, we are only going to concern about this one. We are not going to reciprocate the dividend, only the divisor. So to do that, we have 3/5, 3/5, and we're going to reciprocate the divisor, leaving 5 over negative 7. And then the division operation will not be there anymore, but instead we will be using the multiplication process. Okay, so after we reciprocate, we change the operation to multiplication. Or it could also go the other way. If we change the operation to multiplication, we reciprocate the divisor only. And then after that, we proceed with multiplication of numerator to numerator, denominator to denominator. Okay, so we have here the solution, the answer of 15 over negative 35. Similar to what we have been talking in the previous three videos, if our answer is already a fraction, please stay in a fraction form. No need for numbers with decimal notation. Okay, if the answer is already an improper fraction, please stay in improper fraction. Do not change it to mix. We're lucky that in number one, it's a proper fraction. There's no way it can be transformed into a mixed. And finally, always simplify. We can simplify this one by factoring 15 by 3 times 5. 3 times 5, sorry, 3 times 5. And then you have here negative 7 times 5. Cancellation law for multiplication tells us that we can cancel this out. And the answer will result to 3 over negative 7. The placement of the negative sign could be placed here in the denominator. We could also place here it in the numerator or in the middle, at the middle of the fraction. Okay, so that is how, that's not 4, sorry, 7. This is how we answer division of fraction. We reciprocate the divisor and we proceed with multiplication. This is the longer method actually, but we could actually proceed immediately to a shorter method. And how does the shorter method looks like? It will actually be applicable already in the second step. We have here 5, we have here 5. Leaving 1, same as what happened in multiplication. So when we multiply, we immediately get the answer of 3 because that's 3 times 1, and 1 times negative 7 is negative 7. As mentioned during the previous video on multiplication of fractions, it is now up to you on which you will use, the longer method or the shorter method using the cancellation law. It's okay with me as long as you always consider the correct and the proper mathematical operations. So let us apply the concept of multiplicative inverse to transform the division process in number 2. So you have here negative 1, 6, negative 1, 6 divided by negative 3 fourths. So we could change it into negative 1, 6, right, times 4 over negative 3. 4 over negative 3. Applying the cancellation law or the shorter method, we all know that 4 is 2 times 2, 6 is 2 times 3. So by removing that one by removing the factor 2, for 2 you still 4 you still have 2, and for 6 you still have 3. Not 4 po kasi it should be factor, not addends. 2 times 2 ang 4, 2 times 3 is equal to 6. So when we remove the factors of 2, we still have 2 and 3. So when we proceed with multiplication, okay, we have here negative 2 over negative 9. Sorry. We have here negative 2 over negative 9. Okay, because that's negative 1 times 2, negative 2, 3 times negative 3, negative 9. We can still use another cancellation law here because we have two negatives here. You can cancel the negatives there. Therefore, our final answer is positive 2 ninths. This is similar. This is actually correct when we talk about rules of signs. We are dividing two numbers with the same sign, so we expect that the answer is a positive 2 ninths. Now, for number 3, we have 7 halves divided by negative 2. First, we can transform negative 2 as a fraction of denominator 1. So negative 2 over 1. Next, we can reciprocate this, changing the operation to multiplication. You have 7 halves times 1 over negative 2. So, and proceed with multiplication because there are no more items to be cancelled out. 7 times 1 is 7. 2 times negative 2 is negative 4. The answer is negative 7 over negative 4. Or again, you could always place the negative sign in the numerator or or at the middle. Okay, so it's they are still part of the correct answer. As for number 4, the last item, you have negative 3 divided by 4 fifths. Negative 3 divided by 4 fifths. Sorry for a while. Negative 3 divided by 4 fifths. So we reciprocate the denominator, the divisor, I mean. But first, this dividend can be expressed as negative 3 over 1 and then times 5 fourths. We already took the multiplicative inverse of number of the divisor. And then, since there are no items that can be cancelled out, 3 times negative 7 is negative 15 and 1 times 4 is 4. So the answer here is negative 15 fourths. Or again, the negative sign may be placed at the middle or in the denominator, which all are correct. So what is just new to, not necessarily new, what is actually the process, the unique process for the division of fractions is the presence of multiplicative inverse. Again, do not mix the dividend and the divisor. The divisor is the second item or second number in the division process. That is what you're going to reciprocate. This is our last video for unit number 3 as a whole. Okay, so you need to use these videos as your final review to help you guided. And if there are some concerns, always do not be shy. Do not forget to always contact me if there are some concerns with the module and the practice exercises. You can always make your own problems, and you can always try to search for other expressions, possible practice exercises in other books in the internet for your own benefit. This is the last video for unit number 3. We wrap things up. See you in the next unit. Goodbye.